The ultimate guide to the periodic table and its trends. What is the periodic table? The periodic table is a tabular arrangement of all known chemical elements, organized based on their atomic number, electron configurations, and chemical properties. Who created the periodic table? Dmitry Mendeleev, a Russian chemist in 1869. He developed it to organize the elements known at the time in a meaningful way, based on their properties and atomic masses. A fun fact: there is a famous anecdote that Dmitry Mendeleev dreamed of the periodic table. According to the story, he had been working tirelessly on organizing the elements for days without rest. In 1869, after falling asleep at his desk, he reportedly had a dream in which he saw the elements arranged in a logical table based on their properties.
In a dream, I saw a table where all the elements fell into place as required. Awakening, I immediately wrote it down on a piece of paper. Only in one place did a correction later seem necessary.
How many elements are in the periodic table? The periodic table currently contains 118 confirmed elements. The elements in the periodic table are arranged systematically based on their atomic structure and properties, making it easier to understand and predict their behavior. Here's an in-depth look at how elements are organized. Classification of elements 1. Metals, nonmetals, and metalloids. Metals, found on the left and center of the periodic table, comprise about 75% of all elements. Characteristics: good conductors of heat and electricity, malleable and ductile, lustrous, shiny appearance, high melting and boiling points. Examples: iron, Fe, copper, Cu, aluminum, Al. Nonmetals, found on the right side of the periodic table, about 17 nonmetals in total. Characteristics: poor conductors of heat and electricity, brittle when solid, can exist as gases, liquids, or solids at room temperature. Examples: oxygen, carbon, C, nitrogen, N. Metalloids, found along the stair-step line between metals and nonmetals. 8 elements are classified as metalloids. Characteristics: have properties of both metals and nonmetals. Semiconductors, useful in electronics. Examples: silicon Si, boron B, arsenic As. How are elements ordered in the periodic table? Atomic number. The periodic table is arranged in order of increasing atomic number, number of protons in the nucleus. This is the fundamental organizing principle. Periods, rows. The table has 7 horizontal rows called periods. Each period corresponds to the number of electron shells in an atom. For example, period 1. 1 shell, H, He. Period 2. 2 shells, lithium to neon. Groups, columns. The table has 18 vertical columns, called groups or families. Elements in the same group have the same number of valence electrons, outermost electrons, giving them similar chemical properties. For example, Group 1, alkali metals, 1 valence electron. Group 17, halogens, 7 valence electrons. Blocks. The periodic table is divided into blocks based on electron configuration. S block, groups 1 to 2. P block, groups 13 to 18. D block, transition metals, groups 3 to 12. F block, lanthanides and actinides, below the main table. How does an element look in the periodic table? Categories of elements: alkali metals. Group 1. Highly reactive metals, not found free in nature. Examples: sodium, Na, potassium, K. Alkaline earth metals. Group 2. Reactive metals, less so than alkali metals. Examples: calcium, Ca, magnesium, Mg. Transition metals. Groups 3 to 12. Metals with variable oxidation states. Examples: iron, Fe. Copper, Cu, gold, Au. Rare earth elements and radioactive elements. Examples: uranium, U, neodymium, Nd. Halogens, group 17. Highly reactive nonmetals, often form salts. Examples: fluorine, F, chlorine, Kli5. Noble gases, group 18. Inert gases with full electron shells. Examples: helium, He, neon, Ni, argon, Ar. 6. Lanthanides and actinides, F block. Rare earth elements and radioactive elements. Examples: uranium, U, neodymium, Nd. Key periodic trends: atomic radius, increases down a group, more electron shells. Decreases across a period, greater nuclear attraction. Ionization energy, energy required to remove an electron. Decreases down a group and increases across a period. Electronegativity, an atom's ability to attract electrons. Decreases down a group and increases across a period. Reactivity. Metals. Reactivity increases down a group, e.g. alkali metals. Nonmetals. Reactivity decreases down a group. Thanks for watching.